Welcome to Complanner Studies, and on this YouTube channel, we take care of difficult courses like Calculus 1, which we are going to be looking at right now. And in this video, we'll be covering how to evaluating limits part 1. So I'd like to encourage you to like the video and also to subscribe to our channel to get more amazing content like this one. And I'd also encourage you to share the link with your coursemates who have difficulty with the same subject, Calculus 1. So with all that aside, let's get right into the video. We are looking at how to evaluate limits, and there will be two videos actually. This is the part 1. So first of all, let's start with the concept of functions. We want to define what a function is. And a function is used to describe the relationship between two variables. By variables, you mean things that aren't fixed. So a variable can be x, it can be y. So two variables. And these variables are usually the dependent variable, that's y, and the independent variable, which is x. So as the name implies, dependent variable depends on the independent variable. So you have y is equal to 2x plus 5. So the value of y is determined by the value of x here. And the same function can also be written as f of x is equal to 2x plus 5. They both mean the same thing. It's just that in this case, this is a function notation. We're expressing this equation in terms of the function of x. So that's just the difference between these two cases. So basically, when you're talking about a function, you're going to come across a graph, a Cartesian plane, a graph which has the y-axis and the x-axis. So this is our y-axis here, the vertical one, and the horizontal ones are x-axis. They have both been labeled x and y. So if we want to plot our function, that's 2x plus 5, we can look at the graph of the function here, 2x plus 5. So this is the graph. It's the graph of a straight line. The blue line is the graph, and we get a straight line. So y depends on the values of x. For each value of x, there is a corresponding value of y. By using this function here, for instance, when x is 2, we know that y will be 2 times 2, that's 4 plus 5, 9. So 2 corresponds to 9 on this graph. Now we can see that 2 corresponds to 9. When x is 2, we trace up, and then we see that y is equal to 9. So that's how it basically works. So that's all about functions. Now we move on to evaluating limits, the main subject of this video. So we'll be covering 4 examples. So we take on the first example. We are asked to evaluate the limit as x approaches 2 of 2x squared minus 3x plus 1 divided by x cubed plus 4. So this is a limit notation here. Limit LIM as x is read as the limit of this function. So the limit of 2x squared minus 3x plus 1 divided by x cubed plus 4 as x approaches 2. That's how we read it. So how do we evaluate this? That's the question. So we'll be looking into that. So let's walk through it together. Now it's very simple. Wherever you see x, you just put in 2. It's a very easy way to evaluate the limit. So this is just equal to 2 into 2 all squared minus 3 into 2. So wherever is x, wherever is an x, I'm replacing it with 2 plus 1 divided by 2 all cubed plus 4. So what do we get? We get, you can easily use a calculator for this, or you can calculate it with manual. This is 4. 2 squared is 4, 2 times 4 is 8, so we have 8 minus 3 times 2 is 6, so minus 6 plus 1 divided by 2 cubed is 8, and then we have a plus 4, so our answer is 8 minus 6, that's 2 plus 1, 3, divided by 8 plus 4, that's 12. 3 over 12, which is the same thing as, because 3 can divide both the numerator and denominator. 3 divided by 3 is 1, and 12 divided by 3 is 4. So this is 1 over 4, and that is the final answer here, 1 over 4. So the limit of this function here is equal to 1 over 4. So what does this actually mean? What does this mean? So right here in front of us, we have the graph of our function. The function we graphed is the one that we're taking the limit of 2x squared minus 3x plus 1 divided by x cubed plus 4. So this is the graph of the function. And if you see that if we approach 2, if we're approaching 2 from the left, for instance, the values of y are approaching 0.25. That's equal to 1 over 4. If you can see the black the label that's next to the dots that's moving, you can see it changes to 0.25. The y coordinate changes to 0.25 something. So it's approaching 0.25 as I approach 2 from the right or from the left. It approaches 0.25. So that's why the limit is 1 over 4, which is 0.25. Now we move on to our next example. We are asked to evaluate this limit as the limit of 2x minus 1 multiplied by the square root of x plus 4 as x approaches 6. To evaluate this, so basically using the same procedure. So now we solve it. All we need to do is just replace whenever we see x, we just replace it with 6. And we get the answer. So this just becomes 2 into 6, 2 multiplied by 6 minus 1. This means multiplied by the square root of, if they're joined together, it means this multiplication. So multiplied by 6 plus 4, 6 plus 4. So we just evaluate this. We get, for the first bracket, we get 12 minus 1. Out of this bracket, say 2 times 6 is 12, so 12 minus 1, multiplied by the square root of 6 plus 4, that's 10. So we end up having an answer of 11 root 10. 11 root 10, so this is the answer. 11 root 10. Now we move on to the next example. We have an answer of 11 root 10. So the next example sees us solving this one. We're asked to find the limit of this function here. So I'm just going to write that down. Now we solve it. So as usual, we are just going to put, wherever we see x, we're going to put 3 there. Anywhere we come across an x, we put 3. So here we have x squared, so just see 3 squared. 3 all squared minus 3 multiplied by 3 divided by, on the denominator we have 2 multiplied by 3 all squared minus 5 multiplied by 3 minus 3. So what do we have? At the numerator we have 9, 3 squared is 9. Minus 3 times 3, that's still 9, divided by 2 times 9, 2 times 3 all squared. 3 all squared is 9, so 2 times 9 is 18. So 18 minus 15, 15 from 5 times 3, that's 15, then minus 3. So we have 0 divided by, everything here is 0. 18 minus 15 is 3, and 3 minus 3 is 0. So we get 0 over 0. So the question now is, what is 0 over 0? 0 over 0 is an indeterminate form. It's an indeterminate form. So it's not an answer at all. It's not an answer. This is not an acceptable answer because it's an indeterminate form. So it just means that it doesn't. It's not an answer. It's indeterminate. So once you have this thing, once you come across 0/0, you have to look for another way to solve the limit because that's not the final answer. You have to look for another way to solve it. So since we have 0/0, our substitution method, substituting the value of x we have here into the function didn't work. It gave us 0/0. So what we are going to do here is we are going to look for ways to simplify the function so that we can easily get a real value answer. So we try and rework again. We try reworking. So limit as x approaches 3 of x squared minus 3x divided by 2x squared minus 5x minus 3. So what we can do actually is to try and factorize. Factorizing is one method you can use to simplify this. Let's see if something can cancel out, because in indeterminate forms, a very useful technique you can learn is cancelling out factors. Like you cancel something from the numerator and denominator. You want to see something that's common, you just cancel it out. So it's a very good technique. So we are going to factorize the denominator, and also, okay, let's start with the denominator first. So we are not solving the limits yet. We are just rewriting the denominator in another form. So if I were to factorize this, what would we get? So as usual, to factorize an equation like this, we just multiply the last term and the first term. So minus 3 multiplied by 2, minus 3 multiplied by 2, that's a minus 6. Then we list the factors of minus 6 that can give us a minus 5. That when we add them together, it will give us a minus 5. So we know that with minus 1 times 6, we have minus 1 times 6, we have 1 times minus 6, we have also minus 2 times 3, and minus 3 times 2. I think these are all the possible combinations that can give you a value of minus 6. If you notice, only one number has a minus sign, because minus times plus is minus, which is minus 6. So the question now is, which two factors that when added together gives you a minus 5? That's the middle term. So minus 1 plus 6 is 5, so that's out of the way. Minus 6 plus 1 is minus 5. So yes, we've seen this is actually giving us minus 5. Minus 2 plus 3 is giving us a 1. And minus 3 plus 2 is minus 1. So this is what's giving us minus 5 here. 1 plus minus 6. Or 1 minus 6, which is minus 5. So we are using these as our two factors. So our two factors now are x and minus 6x. So x, because 1x, 1x and also minus 6x. So we just write that there. We see 2x squared, so minus 5x is now being replaced with x and minus 6x. Then we have minus 3. So minus 5x is out of the picture. We just have x and minus 6x. And then we have x squared minus 3x still on top. We haven't left it yet. So remember, we are not solving that. We are just trying to write the limit in another form that's easily solvable. So we continue. We have limit as x approaches 3 of x squared minus 3x divided by, now we group them. Okay, let me just write the denominator as it is. This is how the denominator is right now. But we are going to look for it. We are going to factorize it. So we essentially group them. The denominator, that is x squared minus 3x divided by. So grouping that, we'll have, so just factorizing, just the first two, factorizing the first two, we see that the common, what is common between 2x squared and x is x. So x into 2x plus 1. So the 2x plus 1 here comes from dividing 2x squared by x, which is 2x, and dividing x by x, which is 1, so plus 1. So the same thing goes for minus 6x and minus 3. So what's common between the two of them is minus 3. So it's minus 6x divided by minus 3, that's 2x, and minus 3 divided by minus 3 is 1. So you have 2x plus 1 there. If you notice, these two brackets are the same. They must always be the same. If they're not the same, then you've made an error. So they must always be the same. And we can proceed further to get the limit as x approaches 3 of x squared minus 3x divided by, now this and this, x and minus 3 are grouped in one bracket. And then we have 2x plus 1 in another bracket. So you just group these two and then pick one of these brackets. It's very easy. So we are left here. Now we have factorized the denominator successfully. But the thing is, can anything cancel out at this point? No, because this is x minus 3, and this is x squared minus 3x, and this is 2x plus 1. So this cannot cancel with this because they are not the same. And this can't cancel this because they're not the same. So what can we do? Because we need to cancel out something. A possible thing, what you can do is to factorize the numerator and just get something similar to x minus 3 from it. Because once you factorize it, you bring out x. X is common between x squared and minus 3x. So you just bring out x. So what you're left with is x minus 3. Once you remove an x from x squared, or x squared divided by x is x, and minus 3x divided by x is minus 3. So you have an x minus 3 now at your numerator, which is what you actually want. You have an x minus 3 here and 2x plus 1 here. Now, this x minus 3, if you notice, when we put 3 into x minus 3, you have 0, right? 3 minus 3 is 0. So this is what causes your 0 at your denominator. So the cancellation eliminates this one here. This gives us 0. This x minus 3 gives us 0 because 3 minus 3, once you do that substitution, at the beginning, that's why we had a 0 at the denominator. Because of this factor here, once you put in 3 to replace x, you have 3 minus 3, which is 0. And in the numerator, once you put 3 here, you have 0. So 0 times anything is still 0. So that's why you have 0 times x is at 0. And 0 times whatever is here is still 0. So that's what gave you 0 over 0. So the method here we're using is to eliminate these two. So we cross them out. This x minus 3 can knock off x minus 3, meaning that your 0 causing factors are gone. And once they are gone, you're left with, this becomes limit as x approaches 3 of x divided by 2x plus 1. That's the factor you're left with, 2x plus 1. So now all we did so far was just to cancel out the 0 causing factors. So now we try to evaluate the limits again by using the normal substitution method, just wherever we see x, put in 3. So this is where we actually start solving the limits. This is where the solving actually begins. So we try again, we put in a 3, so what x there is replaced by 3, and on the denominator side we still have 3 replacing the x here plus 1, and this gives us, sorry, there's also no limits here since we've already started substituting, so there's no limits here. We've replaced x. Once you replace x with the value here, you can remove the limits. So what we have is 3 divided by 6 plus 1, which is 3 over 7 as our answer. So 3 over 7, and it's not 0 over 0, it's actually a number. 3 over 7 is a number, it's a real number. So this is the answer. So we got from 0 over 0 to 3 over 7 using the method of cancelling out the zero causing factor. Cancel them out both sides, and once we did that, we were now able to easily evaluate the limits and get 3 over 7. So it's a useful technique, and we'll be using it very often. So now we move to our final example for this video. We have to evaluate this limit of square root of x plus 1 minus 1 divided by x plus 1 as x approaches minus 1. Now we always begin by substituting, right? We just, wherever we see x, we just put in a minus 1. Let's try that. So this becomes square root of minus 1 plus 2, right? Because x here is being replaced by minus 1 from here divided by minus 1 plus 1. Now what do we have? We have square root of minus 2 plus 2, minus 1 plus 2, that gives us 1 minus 1. So square root of 1 minus 1 divided by minus 1 plus 1, that's 0. Square root of 1 minus 1, that's still 1 minus 1, because the square root of 1 is 1. So 1 minus 1 divided by 0, this is 0 over 0. So then we are faced with this situation again, 0 over 0. This is still in the term limits. It's not an answer at all. When you get 0 over 0 by substituting, it's not an answer. It means you have to do something to the function. You have to simplify it, the same way we did in the last example. So let's rework again. So we rewrite the function. We want to see how we can rework. So how can we simplify this? That's the question. So our method here would be to multiply both numerator and denominator by the conjugate of the numerator. Because we are faced, this is a solid function, this is a solid expression here, square root of x plus 2 minus 1. So we want to eliminate this square root here using a technique that involves multiplying by the conjugate. So how does this technique work? The thing is that if you are faced with, if you have something like a minus b, where a and b can be anything, they can be numbers, algebraic expressions, anything. If you multiply a minus b by a plus b, you will end up having a squared minus b squared. So a squared minus b squared is equal to a minus b multiplied by a plus b. This is the difference of two squares expression. So when we multiply this by its conjugate, the conjugate of this is just going to be square root of x plus 2 plus 1. If you notice in these two brackets, here we have a minus sign and here we have a plus sign. So I'm just going to change the sign here to plus. So it means that my a is now square root of x plus 2 and my b and b is equal to 1. You can imagine it like that. So a is square root of x plus 2, b is 1. So If I multiply this by this, I will get a squared minus b squared. So that means my result will be square root of x plus 2 all squared minus 1 all squared, which is the same thing as, now you'll notice that the square here is going to knock off the square root, leaving you with x plus 2 minus 1. 1 squared is 1. So leaving you with x plus 1. Leaving you with x plus 1. So that's it. It leaves you with x plus 1. So you've successfully been able to eliminate this square root here. You've been able to successfully eliminate that. But the thing is that if we're going to multiply our numerator by this, the conjugate, we should also multiply the denominator by the same thing, so as not to change the function. So that was just the background of what we're going to do. So let's execute. Now that we've planned, let's execute our plan. So this will give us a limit as x approaches minus 1 of square root of x plus 2 minus 1 divided by x plus 1 multiplied by square root of x plus 2 plus 1, that's the conjugate I've introduced there for the numerator. And now to make sure that I don't alter the function, I also multiply the denominator by the same conjugate. So this divided by this is 1. So it's like multiplying this part by 1, which is still the same thing. Anything multiplied by 1 is still the same thing. So it means I'm not changing anything. But what I'm going to do is I'm going to simplify it. That's the result of doing this. It simplifies everything. So if we move further, we go to limit as x approaches minus 1 of, now obviously this multiplied by this is the same thing as difference of two squares formula. A minus b multiplied by a plus b is equal to a squared minus b squared. And we also view the we also say denominator, but we'll get there anyway, but we just concentrate on the numerator. So our result is going to be square root of x plus 2 all squared minus 1 all squared. So it's just going to be the square root of this minus the square of this. That's just it. And here we have x plus 1 multiplied by the square root of x plus 2 plus 1. We're actually going to simplify. We're not going to touch this because something is actually going to cancel out. So moving further, we see that this results in the limit as x approaches minus 1 of, so as usual, what I would say is that the squared here is going to knock off the square root. So essentially the square here knocking off the square root, and you're having x plus 2. You just have x plus 2 then minus 1. So we have x plus 2 there, then minus 1 divided by, and the denominator we still have our x plus 1 multiplied by square root of x plus 2 plus 1. We're not touching it, we're still leaving that. Now notice this, that when you simplify further, the limit as x approaches minus 1, this gives you x plus 2 minus 1 is 1. So this gives you x plus 1 divided by x plus 1 multiplied by square root of x plus 2 plus 1. So you notice that this and this are the same, x plus 1 and the numerator, x plus 1 and the denominator, and it's being multiplied by this multiplication. So you can easily cancel. You have this and it's cancelled. And you also notice that if I put minus 1 at x here, the spot of x here, I get minus 1 plus 1 is equal to 0. So I'm cancelling out the 0 causing term from the denominator. I'm also knocking off the 0 causing term from the numerator. And I'm cancelling those terms out. So the result of that, the limit as x approaches minus 1 of 1 divided by square root of x plus 2 plus 1. Now I'm going to try again by putting in minus 1 wherever I see x. And this is the only spot here where I can see x. So it's just going to be 1 divided by 1 because I've cancelled out, this is still the same thing as x. Because I've cancelled out the numerator there, so what I'm left with is a 1 there. So we just put in the minus 1 wherever we see x. So we have minus 1 plus 2 plus 1. So simplifying this, we have 1 over square root of minus 1 plus 2, that's 1, square root of 1 plus 1. Then this gives us 1 over 1 plus 1. Square root of 1 is 1, so this is 1 over 2. So we went from 0 over 0 to 1 over 2. This is actually the real number, which is now our final answer. So that brings us to the end of this video. If you enjoyed the content that you found, please like the video, share the link, and don't forget to subscribe to our channel so you can always get updated if we post any other new content on this channel. This is Complanar Studies, and I wish you a very good day.